All right. Good morning, engineering team. So today we have been tasked by the Olympic Committee to be able to design better safety gear for our athletes. So the athletes have, they've gotten better. They're stronger. They're faster. They're falling harder. So really, what we're trying to do is be able to design better gear so that way they don't get as hurt or just less impact in that regard. So we're going to be building upon what we learned on last week when we were learning about the laws of motion, Newton's laws of motion, and we're going to be able to apply those physics rules in this particular case to preventing the impacts from hurting our athletes as much. So I'm really looking forward to it. I think it's going to be a great lesson. We're going to learn about the golden rule of crash safety, and then we're going to go from there and learn about just how to minimize those impacts. So keep an eye out on this next video that we're going to be playing. It's going to be just kind of give you an idea of what a skeleton crash looks like. Skeleton is almost like a luge type sport that takes place in the Winter Olympics. It's one person just skiing downhill, almost like a bobsled type thing. But it's a pretty cool sport, and I'm really looking forward to you guys seeing what this looks like.
For him. He's actually gaining more and more time as he continues down the track. He's up to 3/10.
Yeah, this is looking like a nice run, and he was definitely making sure that sled was not going to rise too much on the exit of 4. It looks like he took a difficult tap on the entrance of Kreisel there.
Oh my goodness.
Oh, that's such a shame. He had a great run going on there when that happened.
All right, so welcome back. So yeah, that was a video of a skeleton crash. It was a very minor crash. The rider was able to safely get back on the board and seemingly probably walk away. It seemed like he was a little bit upset at the issue of falling, but he was probably kept pretty safe. I think one of the major contributors in that case was definitely some of the engineering of his helmet and also his suit. Was there anything that you noticed that potentially saved him in that regard? Was there something that you noticed about the helmet or about the suit that made you feel as if it protected him?
Well, the helmet was definitely hard,
Yeah,
and then the suit was sleek, so it maybe helped him continue on without crashing too hard.
yeah, great. I mean, the helmet is definitely probably engineered in a way that it has really good padding and cushioning underneath inside. So that's definitely helping to save the skull and probably a bit of the spine for the rider. The sleekness of the suit definitely probably helped to reduce some of the friction. So maybe if on the ice he had a rougher suit, it might give him some sled burns or something like that. So he was able to slide pretty smoothly on the ice. So yeah, good job. I think that the design of the skeleton riders' suits and helmets have probably been redefined time and time again just to help make things a little bit better. So they're probably pretty well designed already as it is. So one of the goals that we're going to try and do here is we're going to try and see if over the course of this lesson if we can find a sport that maybe could have a little bit better safety. Some places where or some sports where maybe athletes are getting hurt, and maybe we can help to redesign and engineer some better safety gear in that regard. And that's what we're going to be doing with today's web quest. I'm excited to get into it, but before we get to that, we're going to go ahead and talk about the impulse formula, and that's going to be kind of going over the physics of these crashes. So impulse actually is the actual crash itself. So that's what is happening, and it's represented as the letter J. So anytime you see J, just know that is the impulse. Now, the impulse is always going to have two components to it. It's going to have the force, or the crash is going to have the force, which is represented as F, and then the actual time that it takes for that impact to happen. So just imagine if you're riding in a car, let's just say, and you're going 100 miles an hour and you hit a wall. That is in a very immediate stop when you hit that wall. Now imagine if you were to hit a box or a ton of sand, boxes of sand, something like that were able to cushion or soften that blow. That would drastically reduce the amount of force that the person is feeling within that car. So with the other half of the impulse formula, we're trying to reduce the amount of time that is going to be happening within that impact. So the amount of time that is shown, or the change in time, the way that we do that scientifically is by putting a delta, which is a triangle, it's represented as a triangle, and then a t. So that is the change in time that is being felt. So here it is, the impulse formula in its completion is going to be J equals F, which is the force, times the change in time. So the amount of time that it takes to crash. So go ahead and write that down. Make sure that that's going to be in your notes there. One of the main things that I do want to talk about with this particular formula is going to be just the inverse proportionality between the force and the time. So basically, if one goes up, then the other must go down, just because they're always going to be equal to the crash. And unfortunately, crashes are, uh, they're not preventable, and crashes will always happen. And there's nothing that we can do, but what we can do is we can try and to decrease the amount of time that's going to be happening. So then that way it will, increase the time, I should say. So then that way it will decrease the amount of force that is being felt by the rider or the athlete in this particular regard. So let's go ahead and do one of these problems on the board here. So then that way you can kind of get an idea of what it looks like. So let's just say the crash, the impact is 100 units, what the rider is feeling. And make sure you're following along, copy this down in your notes. So if the rider is feeling 100, and let's just say the force is 100 newtons, that's what we're going to be feeling there. And then what does that mean if the impact, the impulse is 100 and the force is 100? Raise your hand if you think you know how long this crash took.
It would have to be 1, right?
1 second. Yeah, good job. 1 second. So go ahead and write that down in your notes. Now, let's just say we were to double the amount of time. So 2 seconds, but our crash is still going to be that 100 units. We can't change the crash. That number is still going to stay the same. So if we can't change the crash time, but we can we can't change the actual crash impact, but we can change the amount of time. What does that do to the amount of force, the F part, that's being felt by the rider?
If the time went up,
yeah,
then the force goes down.
Yeah, the force goes down. You're right. Good job. Good job. So then if the time doubled, then what happens to the force?
Would the force get cut in half?
Cut in half. Yeah, perfect. Divided by 2. Good job. So then what is 100 divided by 2?
50.
50. Perfect. So look, we've already reduced our force, so the force that is being felt by the rider, by 2. So good job. So we just increased the time a little bit that the impact is happening, and boom, the rider is able to feel a little bit less impact. So now, given with this particular formula in mind, we're going to take this to the WebQuest, and we're going to be doing some research on some different sports and things. So, go ahead and open up that WebQuest. It's going to be either on your textbook there, or you can go onto it online on your iPad or your Chromebook there. But really what we're going to be doing there is just going to be doing some research. You follow along with that WebQuest, do some research to see what sports could potentially be ones that you would want to go after. So, have your researcher on your team do some research there. Once you figure out a sport that you're happy with, about one that you're thinking that you could potentially improve the gear for, then come back and make sure to run it by me, and then we'll go into it together. We can all look into the different pieces of gear that could potentially be improved upon. So yeah, once we go through that, then now that you've already gotten this down, you pretty much know the golden rule of safety, and that is that if you were to increase the amount of time that it takes for an impact to happen, then the amount of force that is felt is lessened. So that's the golden rule. So we're always trying to just increase the amount of time that it takes to hit let's just say the ground in this case. You have a question?
So yeah, just to clarify, so if we're designing, the sports materials or like items, so should we be trying to reduce the time or like maybe design something that will help slow down the athlete in the event of a crash or some issue like that.
Yeah, yeah, exactly. So, I would say the biggest thing that you're trying to do is trying to cushion the blow, if you will. We're trying to soften the amount of impact that is being felt, and the way to do that is to slow them down. To slow them down. So, if we're able to extend the amount of time that it takes for a particular incident to happen, then it will drastically reduce the impact. So, let's just say, like a gymnast, they perform on like a soft mat, a cushiony mat, right? That mat is really designed to really stop them from being able to, hit the ground hard, because they're hitting the ground softer and it's slowing them down and they're compressing into the ground a bit more. It's taking seconds or milliseconds, I guess, in this regard, to soften them so they don't, hit, let's just say, wood or concrete, something that's much firmer, that will create a much greater force on their bones and their body. So yeah, great addition there. I definitely think that's you're on the right track there. So yeah, now that we've gotten that part out of the way, I think that we should be able to go ahead and jump into that security clearance form. So go ahead and take out your pencil and paper, and we're going to go ahead and jump right into that. All righty, best of luck to you guys.